Alright, so I'm going to be going over the internal logic of LeBlanc. This obviously isn't actually functional. This is just me showcasing sort of what is going on in the background, excluding all of the instruction calls and whatnot. We're looking at operations on the actual variables themselves, which internally are all objects in a sense. So if we see here, I have int a equals 23, int b equals 45, print a plus b. And so we're going to write what this would be internally. So internally, what would happen is that when we see the int a equals some number, LeBlanc is going to create an object. And so let us create an object. So we're going to say int a equals int, object int, and we're creating it with 23. So this right here is our creation of an int. And so this is going to create a LeBlanc object. If you look at the LeBlanc object, it has a couple of different data sets or data types. So we have the actual data, which is from LeBlanc object data. We have the typing, which is LeBlanc types. In this case, that'd be int. So we have the methods as a hash set of methods. We have a couple inherited methods right now. And things are still being added, but there's a couple of shared methods amongst all members, or all types rather. And then we have the members. So ints, any of the native types will be memberless except for probably string. I have to think about that. And then we have variable context. So variable context is specifically, and this is not generated in this example because this is more of a surface level constructor, but variable context would be int a. So it'd be like the name of the variable itself, which is kind of interesting. And I don't think happens very often. So anyways, we create int a there. Let us create int b. So int b, and we're going to create the value 45. So what's happening is obviously we're doing a plus b, and that seems pretty surface level, but this is actually going to be an instruction call to addition. So the addition instruction call because of the plus, and we're going to check if in the actual instruction we're going to check if a or b have the method or the tagged method of plus, or I mean addition rather. So how we do that is we're going to say let method equal a. So we're going to go through the list of methods that a has, and this is again inherited by actually the base object. So we can actually look real quick. These base methods, the base methods are created here. So here is the base addition method. A lot of these are still not fully done, but this has, I believe that this allows a different set of numbers, and we can see right here that the internal add numbers, this is for ints, floats and doubles are different, but we can see that it references itself and then we add it together. So anyways, we're going to take this method or these methods, these list hash map of methods. We're going to iterate through them. So iter, we're going to filter them. So this is where we actually like match the correct method. So we're going to filter. We're going to make sure that the tags contains the method tag addition, and that should be good. And so now we're checking. So this actually isn't fully complete because I don't entirely remember the syntax because it's been about a day or two since I've done it. But basically, we match methods by two ways. So in this case, we're checking to see if the method contains the tag addition. The thing is that in the future, methods are going to have like multiple addition tags, and so we're matching not just by the tag addition. We're also going to be matching by the types that the method accepts. This specific method though, the add method for int a, we can look at it right here. The actual thing takes in all of the numbers right here. So we allow all numbers. Again, in the future, this is going to change. but that is what it looks like right now. Anyways, so we're going to match the method, and we're gonna check and make sure it has the tag addition. And this is all happening in the instruction call. And so if we find the method, so if method dot is I forgot to do this dot last. So if method, actually no, sorry, let me just do dot next. There we go. So if method dot is sum, so we're gonna check if the method is something or if it exists. Then if it does, we're going to then call method dot unwrap dot run, and we're gonna run int a, and we're going to run as args int b. So run, so basically all LeBlanc methods are based on this idea that we pass in it's the self, which is this right here. And even if we don't use self, we still pass it in as self. We also pass in args right here. And so these arguments, obviously, depending on the function, we only grab one, or we might grab multiple. Variable args are also a thing in the future, but and all functions return LeBlanc object no matter what. They will always return LeBlanc object. Just different types of LeBlanc objects. So we're gonna run this. We can say we're gonna actually map it in C. In a print statement, we would never actually map it. We would just let it be. Let me just do that. Let in C equals null. Okay, so now we get the nc back. So this is the result of 23 plus 45, and we can do multiple things. So we're going to first just debug it. So debug print is nc dot call, or not nc dot, just nc, sorry. And so this is going to show us what nc equals. And if we run this code, hopefully it works. So we can see right here that int c, oh sorry, let me just do this, int c dot data. So we can see int c equals 68, and it's in 64, which makes sense because I didn't cast it. So all ints are upcasted to int 64 when adding, at least like currently, and it's up to the actual interpreter to downcast. So we're gonna downcast right here. So downcast to LeBlanc int, because that is ours. So this is, again, this logic is gonna happen in the actual instruction step because we know that these two are ints. And actually what we could do is we could say dot cast to int a dot type of, and so that way we're going to cast to the first argument type, which would be int a. And so now when I do this again, we should have an int of 68, no longer int 64 of 68. And so then we can also int c dot call to string, and then our arguments are none. And so this should also, we can also look at the string, let string wrap equal. So again, as I said, everything's always a LeBlanc object. So even when we do toString, we're getting a LeBlanc object of a string back, and so we can also print that. And the toString method is it's a little bit of a mess right now. It doesn't, the actual like implementation just prints the actual name of the object, but this should just kind of showcase like what would be going on. So what really this should be doing is it should be returning 68 as a string. I can actually do that really fast. Let me do that really fast actually. So methods are actually super easy. So right now in base methods we have this right here, internal to string, and I'll just change the method. So if object dot type of equals LeBlanc type int. So this is just a very, very rough thing I'm doing right here. We're going to return object dot data dot, I don't actually have a way to get that, so we're gonna let LeBlanc objects oh, it's private. Okay, so there's not a way for me to get it actually. That's unfortunate. Okay, so never mind, we're not gonna do this, but I think you get the point. So when I go back to this, so we're going to now print string ref.data, and we're going to see that the toString method does not exist for this. Okay. Well, I didn't expect that. There's actually a chance that I named it something dumb. Let me check real quick. No, I named it correctly. Okay, well, that's embarrassing. But anyways, I'm not entirely sure why it couldn't find toString, but it is what it is. We can even figure that out. So if we look here, this should also go a little bit more into the logic. So we can look into the actual in C, and we can see there's no methods. So I think that's probably because of this. It's because of the cast. So when I cast right now don't copy method data, which is my fault. So we're just going to instead just run it, and now it should work because this in C should have, this in C does have the method. So when we actually have this print right here, we're now printing string, the name of this. Again, this is not the actual correct implementation, but it shows how this works. All right, thank you.